I'm Scott Moore, and I'm a performance engineer. I help to make software and applications faster, better, more resilient. Lately, there's one thing on my mind.
Where's the best barbecue at, man?
So I'm going across the country, talking about performance engineering and barbecue. Join me as we take the performance tour. This leg of the performance tour comes to a conclusion in Atlanta, Georgia. My friends at Shadowsoft were nice enough to host the meeting, and I'm looking forward to sharing the good news about performance engineering to multiple companies, including Datadog, Micro Focus, Qualitest, and Fiserv. The performance tour in Atlanta, and I'm with Bill Hayden. Bill?
Scott, great to see you again.
I have known you for how long?
Oh, at least 20 years.
At least 20 years. Bill and I have known each other through several lifetimes, and we've worked together in different capacities as partners and customers and clients, as competitors and everything else.
I like to call it co-opetition.
Yeah, that's kind of the way I saw it. We go all the way back to Mercury, Load Runner, the original performance testing tool for the enterprise, still around. You've seen a lot of change as well as I have. You've been to a lot of companies who have struggled with performance all throughout the years. So we're now talking like, 20, 25 years they've been struggling with this.
Absolutely.
What are some of the biggest things that you've seen change in IT within the last few years that just like, just up in your mind, you're like, okay, well, it's new, but it's not new,
It's the tectonic shifts. It's not the little incremental shifts where we might have gone from one type of presentation layer to the next. It's when we went from client server to web. And what was the next big shift after that? We went to microservices, but there was a good gap of time between those.
Oh, yeah.
That gap of time between our world fundamentally changing and the skill sets that you and I have to reinvent fundamentally changing is getting tighter and tighter and tighter. Then containers come on the scene, and now all of a sudden we're dealing with cloud native. And just as soon as we get used to cloud native, we're going to go serverless. It's almost impossible to keep up unless you're in a progressive company that's really pushing the envelope.
If we go back to the old QA conversations that we've always had, people have always struggled with functional issues, automation and testing and getting ramped up on that. But specifically speaking from a performance perspective, have things really changed that much? Because, fundamentally, if something's slow, there's only so many causes that it can be, right?
It's true. When we first started out, we were so focused on generating the load. And then we finally realized, you know what? The real money is in the analysis. How can we pinpoint the root causes and then work with development to fix it? But we always had the issue of being able to reproduce a production environment in test. It was hard to compare apples to oranges when we see a certain amount of throughput, a certain amount of time in one environment, and then it would behave completely differently in production.
Right.
So how did industry respond to this? They said, you know what, we don't need performance testing, we need performance engineering.
Right.
Everything shifted towards instrumentation of source code, and we were troubleshooting things in production, hopefully as fast as we possibly could. You saw that with the emergence of the new relics, the app dynamics, the redesign of Dynatrace. But now I think we're finally getting smart enough to bake it into the beginning of the process. It's things we've been talking about since the early 2000s. If you're going to write that code, is it really optimized for speed? If you think about if I'm doing a transaction on my cell phone and I have no tolerance for anything over 5 seconds, 4.7 seconds of that may be the network that's out of my control. So I'm down to 0.3 seconds that I have to optimize inside my firewall. Every millisecond's going to count.
All along this way, I have talked to dozens of companies and dozens of people within those companies. And the information, while it's just anecdotal, that I have learned about the need for performance testing and engineering, it's crazy. The same problems keep cropping up. And nobody has been giving me what I feel like are complete solutions. So I don't think anybody has the answer, but maybe we're getting closer to that. And at the end of this, I hope to put out some research that'll help tell the vendors, like Datadogs of the world, plus consulting organizations, maybe what you can do, what these customers are really asking for, what they're having trouble with, and what you can help them solve.
And really the transformation I've seen, which has kind of fascinated me, has been taking this sort of just-in-time optimization that we apply to compilers and interpreters and moving that to like the whole development cycle. And what I've seen a lot more organizations embrace is this idea of we're not going to prematurely optimize in the design phase. We're just going to get that minimum viable product up. Then we're going to see where our bottlenecks are. And then we're going to do that optimization in kind of a more iterative, responsive approach. So it kind of takes that need to do this front-end design optimization off the table, and people don't even worry about it. They don't have to be experts at it up front. And knowing that as long as they have good visibility over the application, they can fix it later. But that is a trade-off of design to, you have to have expanded visibility to make it work.
So if you're running minimal viable product, is it viable if it just performs well for one, but it doesn't perform well for many?
Well, I think that's the idea, is that if we have a development cycle which can operate in a day as opposed to in a month, then we scale, we write the product for one person, and when 10 people get on it, we see where the cracks form. And if we have a solid monitoring strategy and visibility across the platform, then the next day we fix it for 10. And the next day, if 100 people get on the platform, the following day we have it working for 100. But what I've seen is that this only succeeds, number one, where you have that visibility, and number two, where your efficiencies are in the development cycle as well as in the application.
Your perspective in 2020 as to what is a single pane of glass in your mind?
Yeah, a single pane of glass to me starts with the end user experience, and it starts with matching the business process. And then we dive deep into the geekdom that we all know and love about server resources and app stuff and what the JVMs are doing and all that thing. It has to start with the end user in mind. All right, this is Spiced Right Rib House Barbecue, and we have pulled chicken, pulled pork, looks like potatoes, maybe, hash browns. This is their southern hash browns, collard greens, my favorite, baked beans, plenty of sauce, and bread, the way you're supposed to have. And this is bread pudding, which we'll have a little bit later. All right, so I'm tasting this Spiced Right Barbecue, and I use the hot barbecue sauce. It's moist, it's not dry. The hot sauce is red and sweet, but it's got a little bit of a vinegary taste. The chicken is actually pretty awesome. It's not your regular pulled chicken. It's like, you just don't have to worry with the bones, right? Collard greens. If you people do not know what collard greens are, you've never had real collard greens, you're missing out, and your life isn't complete. I'm just gonna say it. You can tell they seasoned it right, and they cooked them a long time. You can tell a good barbecue place by if they pay attention to the sides. And don't forget the sweet tea. If you're going to do this sweet tea right, just get out of town. Seasoned with some of the meat. And finally, the potatoes with the cheese. Kind of like a baked potato, but loaded all the way, just the way I like it. I'm gonna say on a scale from 1 to 10, this is probably 7 to 8, which is really, really high on my list. So Spiced Right Rib House, you got it right. You get the thumbs up from the Performance Store. So I am here with Mr. John Ray. And John, why don't you tell our audience who you are and what you do?
Sure. So my name's John Ray. I'm a practice manager here at Shadowsoft. I'm involved with the day-to-day operations of our cloud solutions and DevOps business.
So I noticed that here Shadowsoft does cloud, DevOps, containers, and monitoring, and part of that's got to be performance, right?
You know, it's funny because there's not really a huge focus on performance as a segmented off category, but it's hugely important to all of these things that you mentioned. The whole point of DevOps is to be able to deliver code at velocity, and in order to do that, you have to be hyper efficient in all of the stages. And so when you look at that, it's very much in line with the ethos of performance engineering to begin with.
So the question that I have around this it's come up with throughout this whole tour is when you have a group of people in DevOps and you have site reliability engineers, there's this expectation that, hey, everybody understands performance, the fundamentals of performance engineering, capacity planning, blah, blah, blah. You find that that's true, or is that a challenge?
I find that it's a challenge, actually, with most of our clients. Performance, like security in a way, has become almost an afterthought in a lot of scenarios. People seem to assume that adopting a new technology like containers is automatically going to bring a performance enhancement. So a lot of times they aren't looking at things like, what is the underlying hardware actually doing?
Do you think it's fair to expect people right out of the gate to come into a company? I mean, maybe they're right out of college, or maybe they got a couple of years of IT experience to really understand performance. Because, I mean, honestly, I don't know where you can go to learn this stuff. Where do people actually learn the chapter about performance and performant code and setting up containers that we know how much memory to put in them? We know how, like you were talking about, knowing how the threading works. And where do you find that out?
You know, unfortunately, you find a lot of it out on the job. I don't see a lot of people thinking about that at the forefront of what they're doing. Most folks are like, I write Python code or I write Java code. And there's not a lot of thought put into what does this do to the entire system. Everybody kind of focuses on their little piece. And from a management perspective, a lot of folks think, well, I'm just going to assume that my systems engineer knows that it needs to be performant.
Right.
Right? We've gotten to a point now where we can just throw more and more RAM at it, more and more machines. Things like AWS, hey, if your application is not performing well, scale it vertically, scale it horizontally. That's always the conversation is always around scale. And how do we optimize the scale of things and schedule, I want a cloud burst and all this type of stuff. And not a lot of folks take the time to take a step back and go, why am I having the cloud burst to begin with?
Exactly. Is there any one thing that you could say is probably one of the biggest obstacles or biggest problems in performance engineering that we need to try to overcome, or maybe even offer a suggestion of how we can overcome that? What's something that you can offer the viewers of the tour to say, hey, if you're thinking about performance, we got this problem, but here's something we can do to fix it?
I think there's a couple of things. The first is that throwing a new tool at it is rarely ever going to increase performance. And certainly throwing another abstraction in the way is guaranteed to negatively impact performance. The more abstractions you have to give somewhere, and it's going to come from the performance of your application. So that's the first thing, is to say, don't just throw tools and abstractions at things and think you're going to get some kind of massive performance gain. The second thing, I think it's very, very important for both the practitioners, the people actually operating the systems, and also for the business owners to think about performance and to ask the question, how performant is my code, for example? The way that AWS is moving their billing to, it's per CPU cycle. So if you think about serverless code, if I have two functions and one of them takes 10 clocks and one of them takes 3, not only is this a difference in speed in some cases, but it's a difference in cost.
Yep.
It becomes infinitely cheaper for me to run this function. And so as a business, we have to start thinking about things like, yeah, this is an eighth of a second slower than this, but it's 35 cents cheaper.
Right.
So now am I willing to give that up?
We have a direct cost to poor performant code and the impact that it has on the bill, which I think is a great thing.